Arkadaşlar, if we start talking about continuous time convolution integral, okay, I will focus on the basic understanding. Now I will have x of t, and my system will be characterized by h of t, which is my impulse response, okay? This is my input, this is my impulse response, and this is my output. So if I know input of my signal system, if I know the impulse response of my system, I can immediately determine the output of my system, okay? So if we talk about the integral here, it will be very similar to the previous integral. Now I will have from minus infinity to plus infinity x of tau times h of t minus tau d tau. If you remember, the discrete time case was like this. If you look at them together, they are really very similar to each other. N minus k. So integrals, summations become integrals. X of k, now it is x of t. So what should I do? X of tau. So the first thing I should do is from x of t, I should convert to x of tau, another variable. And for what did we do for h n minus k? We converted h of t into h of tau, and then we took h of minus tau to find out the time reflection, like going to from the right side to the left side, and then shift t seconds to the right if t is positive, like minus 1 second to the left if t is 1 minus 1, okay? We will follow the same things. What were we doing? We were multiplying the overlapping samples and then summing them up and then writing the output to the nth sample of the output. We will do the similar thing. Now we will have t second shift, and this t will be the time value of the output at this point, okay? So if we continue like that, now let me explain this using one example, okay? This is like e to the power minus t ut arkadaşlar, and h of t is given as, let's say, u of t, as we mentioned in the other discrete time case. I'm going to apply this formulation right now. What should I do first? I will convert this into x of tau is equal to e to the power minus tau u tau. I will convert this into h of tau is equal to u of tau. Then convert this into u of minus tau. Then convert this into u of t minus tau. Okay? Now I'm going to write my integral. Y of t is equal to, from minus infinity to plus infinity, I'm going to write this as it is, e to the power minus tau u tau times u t minus tau, and the tau will be my integration variable, okay? So what should I do next? I will look at these two to determine the boundaries. From here, what should I say? Tau is greater than 0. How about this one? T minus tau is greater than 0. That means tau is less than t, okay? How am I going from here to there? Like if I move this towards here, t tau is less than t, right? So what does this say? This should be equal to 0. What does this say? T tau should be less than t. So this one should be t. Okay? We are trying to find out the boundaries using the u of t's, okay? What do I have finally? Y of t is equal to, from 0 to t, my integral variable is tau, so it should be e to the power minus t times 1 times d tau, okay? This is 1 in this interval, this is 1 in this interval, so I can easily neglect these and then obtain 0 to t e to the power minus tau d tau. Okay, easy, right? Then I will find out minus e to the power minus tau from 0 to t, because this one goes down. Then I will put this one minus e to the power minus t minus e to the power 0, right? If I put 0 here, then it will be 1, minus 1, minus minus 1. This part is 1. So the final value is 1 minus e to the power minus t. Okay, this will be my output. So what was my input? My input was like this, e to the power minus t ut. This is my input, x of t. What is my output, y of t? Again, there is no output before 0. And this is like 1 minus e to the power minus t. Now I will have 1, when t is equal to 0, this will be 1. And then I will have this kind of an output, right? So 0 when t is equal to 0. When t is equal to, let's say, 1 over 2 e to the power 1 over 2 root e, okay, 1.4, 1.8 or something like that, maybe less. And then it should be dropping down as we increase. This value will converge to 0. 1 minus 0 will be equal to 1, okay? So this is 1 minus e to the power t ut. Why is this ut? Because it is 0 before 0, okay? So this was the initial part of the convolution integral. I hope you will watch these videos and together we will solve much complex questions together regarding the convolution sum and convolution integral.